I don't see. Any make me host. Let me share this thing fast. Let's start.
I not see your body.
Sam,
All
are you
right,
going to do
guys.
that first
All
link
right,
length?
guys. Let's move. What do you say?
That first link length. I did not see it too.
This is it here now.
And like I did not see how you did this network.
Okay.
Can you guys meet?
Yeah, mute. We're about to start. Thank you. Okay, I'll just go about this one again. The first one. I said this is not link length, it's link twist. That's the alpha. It's the rotation of frame 0 to frame 1 along the x1 axis. So irrespective of how the frame looks like, just try and rotate this frame 0 to frame 1 along the x1 axis. And how is the x1 axis like this? It is here. So what is around this place? It is x naught. So we are taking x naught and rotating it till we get to this one. And that is like this, making this one come here and this one come up. So we are going to have what? 90. So basically we are doing the same thing now from frame 1 to frame 2. So along which axis? X2 axis. So we are rotating this to this, but there's no need for rotation because y1 matches with y2, z1 matches with z2. So this is 0. Do we understand? Or I should go over this again?
Makes sense.
Makes sense, but any other
Yeah.
person, any objection, any, because
Go
if you
right.
don't understand this,
Please go right.
let's,
Oh,
My phone almost fell. Just one. Just one.
I should go over it again. All right.
Yeah, thanks.
So the rotation of this, see, theta, the definition of theta is the rotation about z. I think that's the surest way to put it now, so you guys can understand this. As we go higher, maybe you'll be seeing a better definition, or maybe a little bit more complex. But now, the rotation of alpha, the rotation of theta is rotation around z. That's why the rotation about this frame to this frame around z was theta 1. The rotation about this frame to this frame around z, irrespective of what they look like, was theta 2. Now, alpha, in the other hand, is the rotation of the first frame to the second frame around x1. The last one is the rotation of the first frame to around to the second frame around the first z, which is z naught in this case, which was this one. This one was this one, because we're always referring to the previous z, but this one we're referring to the new x, not x naught here, not in the direction of x naught, in the direction of x1. That's why the direction of x1 was like this. So we had to rotate this to this around x1 direction. And what was x1 direction? It's still the same thing as x naught. So we just rotated it like this. Z came here, y came here. That was 90 because it's the negative anti-clockwise direction. Then this around x2. X2 is already here, so we try to rotate x1 with it. Y and z are already in line, so we don't need to rotate it to anything, and that's why this is 0. Who still don't understand that?
Good to go.
Okay. Now, we want to get what's the name? R. What we need to understand is that R and D, they are not the same thing. You will see that now when we start the kidney first. Okay. R is, what is R? Displacement parameter. So it's called okay, I wrote D first. Let me just stick with the one I used in that tutorial video. R and D. Some people call this A, but R, just know that R is part of our displacement parameter. It's our link length, and D is displacement vector. So now, R, what is R? The definition of R is the displacement along xn. Displacement along xn. I think I'll be using n now so you guys can understand it, because what is the formula for this? It's always R n minus 1 n. So in case now when I do with frame 0 1, that's this will now be what? Frame 1 minus 0 is what? 0, and what? 1. So now we are dealing with R1, this one. So now Sorry. If they say n, xn, what's our xn? Is x1. Assuming they say xn minus 1. If they said r is the displacement along xn minus 1, then it would have been x naught. But they said r is the displacement along xn. So which is what? Our xn is definitely x1. Who doesn't understand what I just said now? N minus 1 and n. Who doesn't understand it? Let me explain it again, please. Please, I want a response. I know somebody don't understand it. If you don't understand, let me just explain again. Okay, let me explain irrespective. N and n minus 1 is not. See, okay, let me now define everything I've said using n and n minus 1. Theta is the rotation of frame. The way they put it in that definition, frame n minus 1, which in this case is 0, to frame n along what? Z n minus 1, which is what? Z naught. Alpha is the rotation of frame n minus 1, which is this, to frame n, which is 1, along what? Xn, not xn minus 1. Now, R, they are telling us that R is the displacement between these two frames along xn. What is xn? Xn here is x1. So our alpha here now. So who wants to try what our first one is? Our first R is. Anybody? I want anybody to try.
0.
Nobody's trying. Displacement of this frame to this frame in this direction. Please, someone should
Is it
try.
error?
Are you serious?
0.
Okay, I can't hear you. I'm sorry. My microphone disconnected. The goat, Sarumi.
0.
0. Thank you very much. It is 0 because they are in the same. Please mute yourself, that person. Yes, thank you. Because they are in the same axis. Assuming this one was somewhere here, let's assume this frame was this place. It would have been A2 because there was, there have been a
Sam, I
displacement, an
can't see your
actual
cursor.
displacement.
Use your cursor now.
This one, is this not cursor here? I've seen it. Are you seeing the cursor?
Okay.
They are in the same axis, so there's no displacement in this direction at all. Assuming this frame, assuming we are doing with this frame and this frame, then the displacement would have been A2. So I've given you the answer to the second one already. Yeah,
Sam, I swear, I
because-
didn't see your cursor.
Are you kidding me? Who else is not seeing my cursor? This is my cursor now, Latif.
We can see that.
Is that not my cursor you're seeing? The one I just wrote C now.
Yeah, we can see it.
Yes, so I'm
Where
saying
you
the
wrote
displace. Oh God.
Okay,
Which one is it?
maybe his network.
It's your network, guys. Stop using glue. The displacement between this and this is what we are talking about. In this direction, R is the displacement between frame n minus 1, which here is 0, and frame n, which here is 1. Simple mathematics, n minus 1. If the answer is 1, so you know what we're talking about. Between n minus 1 and 1 along this direction. But now they are in exact same thing, so the displacement is 0. 0, chicken, now no displacement at all. Now let's now look at it the other way. Sorry, the second one. Oh, what am I doing? Now the second one is the displacement between this frame and this frame. In what direction? In x2, not x1. Though they are in the same direction, but this one is in x2. So what's the displacement between this frame and this frame in this direction? Is A2. Who doesn't understand it? Let me go over it again. Guys, we need to be fast. My phone is very low. Who doesn't understand it? Move on. We should move on. All right. So you what? You understand it? Okay. So now the next one. Oh God, I'm sweating. Man. The next one now is D. D is the displacement. Listen, D is the displacement of the frame n minus 1 and frame n along Z n minus 1. You see all these parameters, the definition are the same thing. It's just that one is zn minus one is x. If the first one is z0, the next one will be x1. If the first one is x1, the other one will be z0. It's just z0 x1, z0 x1. That's the relationship between these two and these two. This one now is the displacement between this and this in the next axis, not the previous axis. This one is the displacement between this and this in the previous axis. So it's very simple. What's the displacement between frame 0 and frame 1 in the previous axis, which is what? In the z previous axis. So the displacement between frame 0 and the displacement between frame 1 in the zn minus 1. Please, who can tell me what that displacement is?
A1.
How far are you now?
I know Sabino.
I wanted to call name. You get them.
Oh.
All right. Then the
But
second
you said
one.
somebody now, no vex.
No, I wanted to call him. You don't worry, you got it. The second one now, okay, is now the displacement between this frame and this frame along which axis? Along the Z1 axis, not Z2
Zero,
axis.
zero.
Oh yeah, boss. Okay, guys, let's take one more. We're supposed to take two more examples, but let's take one more example for my.
So Samuel,
We are done with
Samuel,
this.
I
That's
just want
it.
to
Yes.
confirm something. I want to confirm something. So for D, we are looking for displacement along the previous
Previous
Z axis. Then for
yes.
R, we are looking for displacement
the
along
displacement
previous X.
The next X, which is the current X. You get?
Wait, I don't
If
get
you are
like
dealing
with
See, let me explain it. For D, we are looking for the displacement along the previous Z axis. For R, we are looking for the displacement along the current X axis. I think that current and previous just deals with the Zn minus 1 and Zn. I think that's the problem. You get?
Okay.
The R is the displacement along the current one. So R now, look at this, how we got R0 was the displacement between this and this along the current X axis, which was this. You get? So that was 0 because it did not move at all. It's not moving in this direction at all. So that's that. So is there anybody now does you understand how we got this homogeneous matrix? Sorry, how we got this DH matrix? Anybody? Who doesn't understand how we got this DH matrix here like this?
Okay, sorry, like it's more of like a summary of everything to get
exactly.
Theta is like the angle along the current z, and that's the previous z. That's for the first one. It was for z naught. Then the alpha is for current x. I be the displacement, the angle.
The rotation around current x. Yes.
X.
Yes.
Okay, I
if
grab
you, if you just know these two. If you just know that these two are rotation parameters, these two are displacement parameters. Rotation like displacement, distance. If you can get that, it's very simple. Then you just know that this one is the rotation of the first frame to the second frame along the previous axis. Then you know that this one is along the what? Current axis. But this one is previous Z. This one is current what? X. You get?
Yeah.
This one now is what? Current X. That's why I see some textbook they'll put D. If D and R they can put D, so you can just rhyme previous current.
Samuel.
Yes.
That's alpha. You said current X. You said theta is previous Z.
Yes,
current
previous
is it
Z.
current X or be current Z?
Current X. This one is not current X too. And this one too is previous Z. But remember that these two are rotation parameters, these are displacement parameters. That's what I was saying. Some textbook, instead of using alpha, instead of using R, they'll use A. It will not be theta, alpha, D, and A. So that you can just rhyme previous current. But these are the one in the tutorial video I'm doing. Either way, just know what you are doing. That's it. You have gotten it already. So can we proceed?
Yes.
So we are done with this now. We are done with this, like this question now. So this now like the DH parameter. Now instead of calculating the homogeneous, calculating the joint variable, calculating the homogeneous, joint variable, frame rotation matrix, homogeneous matrix, this DH gives you everything together. Everything together. These are these DH is. I wish this. Okay, that's why I need to go to the next one. The next one we say that is a 3 it is a that's 4 frames. That's 3 frames, 4 frames actually, but frame 0, 1, 2, 3, 4. Let's go to the next one. I don't think I have a screenshot of that. So let me just go to the YouTube video and get the stuff. I think I started already. Let me just check from Naomi. Okay. Sorry. All right. So this is the next. Yeah. I'm sorry, guys. I'm not there already. Okay, guys, let's start. So I think after this, we'll just end this. Maybe Naomi was telling me something earlier today that we need to work on um, because some of the questions Engineer might give us, this is more of 3D. I don't know if you guys understand what I'm saying. Like the one you gave us in the last slide now. We are seeing that actually it was a manipulator, but we're not seeing this spherical stuff. If I'm talking like this, you guys will not understand me. So let me just go to Naomi.
Ilele.
Be coming down now.
Who muted me? Are you people okay? You guys are not serious. What I was saying is that in the question, I might be getting something like this. This now is different from. Please, who is that person? Mute yourself. This now, this now is looking different from the way we are seeing it here. You get. So I think we are maybe going to have one more class to talk about this, to do an example on this actually. See how
Samuel, this diagram now,
Nice.
this diagram now, can you convert it to that that
I've not
diagram
yet
that is
mastered it. I've not yet mastered it yet. That's why I'm not teaching
Okay.
this class. I can't teach what I don't understand. I understand how we did everything, but the X, Y, Z is still confusing to me because this is actually how the robot looks like. Not real life, not him putting it in this form. You get. So let's master this form first. Let's master this form first before we now do that one. All right. So after this one, we are done with today's class. Okay. So as this is like this now, okay. So we have this is a Takwa. This is a SCARA manipulator. The one I was telling you that it will first go up and come. It usually have like a double length link twist or whatever between the first rotation and the second rotation. This is a SCARA RRP prismatic. All right, and so the theta displacement, whatever. And now we have A1, A2, A3, A4. Yeah, I watched the video and she made a mistake. She admitted to it and corrected it in the end when she wanted to do the displacement vector. Year to year is A5. Year to year is A5. This year to year, this small place like this here is A5. A5. So
Why?
let's start. Eh?
Why?
From here to here is a displacement. From here to here is a displacement. This small one cannot be ignored because just like this displacement now covered the whole of from here to here. Assuming displacement cover from here to just this top is going to be wrong. Displacement have to cover like you know what displacement is now? Distance in a okay, is it distance that is a scalar quantity or vector quantity? Just know displacement is just distance in any direction at all. So we still have to know what this is. In the question she did
Vector
actually,
quantity.
okay, that's we'll see. All those one are pass. Just know that this is the A5. Assuming I had to label it correctly, it would have been
There's
A1,
no
A2,
A3.
A3, A4. That's what I'm saying. Is depending on how you label it. If it giving you and it's giving you and you put A3 there, still correct. Nothing changes. Normally it would have been A1, A2, A3, A4, A5. Then don't forget that there's a prismatic here. So put this, it did not put D1, it put it D3 because this is the third frame. So the first thing we need to do is to label this frame. So this is frame 0, right? This is frame 1. This is frame 2, right? And this is frame 3. So we are going to look for our DH parameter now. All we need to do is that we are going to, and no matter what, we are going to have what? We are going to have 4 columns. And how many rows are we going to have?
4. I mean, 3.
Yeah, we are going to have 3 rows. Lekon. Joshua is not home. Okay. Now, the first thing now is what? Our theta. So, anybody want to give it a try? Talk now.
The first one is theta 1.
Is theta 1.
Kilo D.
Yeah, I killed that phone.
I did see that wrong.
Like this guy is out again.
And you guys said the first one is theta 1.
Yes.
Yeah.
Can you cancel that stuff? Go.
Why theta 1?
The rotation about the Z on the first frame now.
You have not convinced me now. I'm not hearing anything.
I said the rotation about the Z naught, that's the Z on the first frame, the previous Z, that's the starting Z.
Who doesn't understand? Who doesn't understand? Yeah, you are right. You are right. Senior Japheth, you're actually right. Who doesn't understand what Japheth just said now?
I'm calling Senior Japheth.
You are senior now.
Honorable Japheth.
Who doesn't understand? Some people are silent in this class. Let me call you. Alimat, talk. Who is iPhone? Who is iPhone?
That is Latif.
Okay, no, Latif is talking. Mesoma talk. Okay, take you to his talking. Alima Mesoma talk. Yes.
You said there is A5 at a position. Where is it?
Yes, who's that? I said the mistake. Meet yourself. Oh my yeah. Thank you.
No, I will do that.
I said the mistake she made is that when she was labeling, she said A1, A2, A3, A4. She skipped this small part. It was in the end when she was doing all this D stuff. She now noticed that yes, this place should have been labeled too. Okay, let's just change it for our own case. Let this be A3, this be A4, and this be A5. I think it'll be better that way. Is it okay like this now?
Yes.
All right. So I said, who doesn't understand how Japheth got this place to be theta 1?
Javu. Talk.
I said that Limat and Misoma should talk. Both of them are keeping silence.
I don't
I
understand.
understand.
Who said he doesn't understand?
Sarumi.
I said that theta is the rotation of frame 0 to frame 1 along the previous. Meet yourself, please. Theta is the rotation parameter, but the rotation of frame 0 to frame 1 along the z axis, the previous z axis, which was z1, and here it will always be theta 1. Then the second one, we also know that it's very simple stuff. What's the rotation of this frame to this frame along z axis? It's theta 1, just this theta 1. You don't need to rotate it to match. That's the problem. You don't need to rotate it to match. What just that rotation is theta 1. The second one to call. What's the second one, please? Theta 2. Thank you. It's very simple. The third one call. So what would be the answer? Zero. Please, is there anybody that don't understand this first part that we just did now? Please, I don't mind going over it again. This theta 1, theta 2, and 0. Who doesn't understand it?
Samuel, explain again.
So now you can talk. I said.
Are you sure you are in this class?
Please, let's mute ourselves. I'm using earpiece, and that place is very loud. Please. I said theta is rotation of the first. Theta is the rotation of the first to the second along the previous z. So what's the rotation of this to this in this axis? Because that's where the z axis is, and the rotation here is just what theta 1. The problem is that you don't have to rotate it for it to match. Look at it now. Okay, look at this axis and this axis. Assuming we're rotating to match, won't it be 0? Because this frame is exactly the same thing as this frame now. Abi now, y is facing here, x is facing here, z is facing here. Then the rotation will be 0. But no, we're not using 0. We're putting theta 1. It can rotate to anything we like. What's just the rotation along the z axis of the first one? Simple. The second one, what's the rotation of this axis to this axis along the z axis? It's also theta 2. The third one, what's the rotation of this to this along the z axis? There's no even rotation at all here. Why? Because it is prismatic. So there's no rotation. It's only moving forward and backward, like I explained that day. So theta 1, theta 2, 0. Who doesn't understand this again?
Hello.
Yeah.
Another announcement.
We have 10 more minutes, so you have to be fast.
It will be ending in the next 10 minutes. Hey, oh.
Yeah. So we'll have to put another next to finish up.
Oh yeah. Let's move. Moving on. So what's alpha? Mute yourself, please. What's alpha? Alpha is the rotation of this to this in what? The current x. So what's the rotation of this to this in the current x?
0.
This is exactly. Thank you. Because this is not the place we now have to compare. But z1 and z0 is the same. Y0 and y0, y1 and y0 is the same. So it's 0. Moving on. The rotation of this to this along the current x. What's the current x? This is the current x. So we are rotating this. It's not this frame we are rotating. No. It's this one we are rotating. So how can we rotate this along this direction to get this? Yes, anybody, please. This is very simple.
Anti-clockwise 180. That's
180.
positive 180.
Yeah.
So if you say positive 180, anti-clockwise 180, that's positive 180. Thank you. Then the third one, how can we rotate this to this along which axis? The current what? X axis. So this current X axis. So X3, how can we rotate those two together? Oh yeah.
They're the same, 0.
It's no rotation. There's no rotation.
There's no
It's 0
rotation,
now.
so it's 0.
Yes.
Thank you. It's like we're even faster now. Let's beat the time. The last one, which is R. What is R? The rotation, the displacement of this to this along the current X. So what's the displacement of this to this along the current X? Oh yeah.
Not the current x, negative a2.
X.
Why negative? Why negative?
The x
Just
is facing
A2.
towards the right now. The X is facing towards the right. Okay, or the sign doesn't matter. It's just the
I don't think the sign
displacement.
matters. Displacement
Yeah.
is displacement. Yeah, just
Okay.
A2.
Okay.
Just A2. The other one now, displacement between this and this along the current X2, which is this. And that's what?
A3.
A3.
A4.
A3.
Is A4.
Sorry now. Oh, we have labeled our one as A4.
Yes, it's
Sorry,
A4. It's A4.
let's stick with our
Oh,
one. A4. Yeah, sorry. Then the last one, that's the displacement of this to this along the what? The current X. What's the current X? Is still
That
here.
is 0.
It's
0.
Thank you. Now the last one, which is the displacement of this to this along the previous Z axis. So what's the displacement?
That's A1.
Like this?
A1.
Thank you. Then the displacement of this to this along the previous Z axis. That's what?
A3.
A3. Thank you.
A3. Yes. A3. Yes.
Then the last one. What's the last one?
A5.
A5.
A5. Wait. Is it A5?
A5, yeah, A5.
Okay, yes,
I
it's
love
A5.
I love
5 plus B3.
Thank you. Oh, God bless you.
A5.
Jaffe. You not die
No,
young.
it's true. A5.
Okay.
There's a prismatic.
Guy, I'll say it.
There's a
No
prismatic.
vex. No vex,
Guy.
boss. No vex, boss.
I swear, I'm angry. I'm honestly angry,
Oh,
especially
someone
with
got
all of you. And now it's only one person. Is that good enough?
No vex.
There's a prismatic, so don't forget this prismatic. It can extend and come back. So it is from here to here, which is what our A5 plus D3.
Okay.
So that's the end. Actually, I don't think we might need another.
No vex, boss.
So who doesn't understand homogeneous now? Who doesn't understand homogeneous?
Samuel, please, can you explain that how you get that 180 in that alpha, please? I
This
didn't really understand.
Alpha is what? The rotation of this. That's the second one, Shady. The rotation of this
Yes,
to this along the what? Along the what?
the x axis, the current
The
x.
current
Abi.
X, which is here. So how do we rotate this to this? That is, we are rotating it in this what? This what X1,
Yes.
like this, right? And if we
Okay.
rotate it this way, the only way that this Z can come to this Z and this Y can come here is when this Z comes to
Okay, yes,
180.
yes.
Then this
Okay,
Y2
I
comes
grab.
180, so it can face here. So that
Okay.
it is what
Yeah.
the anti-clockwise direction, so it's 180. So who doesn't
Yes,
understand
yes.
this? That's DH for you guys. That DH that people are thinking is hard. That's it like that though.
Wow.
Thanks, boss.
Thanks, boss.
So, hold on, see, no, don't be one yourself.
And
So
so-
instead of doing frame rotation, joint variable rotation matrix, homogeneous transform, if you just calculate the DH, all you just need to do is to what? Just input the parameters. So now look at now the standard stuff for homogeneous matrix. Now for this SCARA, this same manipulator that I just did. What manipulator is this? This is SCARA, right? Rotation, prismatic. That time that we did it in year 3, that time that we did cos theta, sin theta, we're doing all the computation and everything. The standard stuff that time was cos theta n, sin theta n, 0, minus sin theta n, cos theta n, cos alpha n. See, I don't need to write all these things. Just know that from that standard formula, remember that our displacement was what? Using that SOHCAHTOA stuff, R n cos theta n, that's for the x. Then for the other one, which is y, it will be sine. Rn sine theta n. Then this place is our what? Just our normal displacement because z doesn't have any alpha cos or sine. Then here is always 1. You get for a particular manipulator. This is for SCARA manipulator. So assuming we are asked to look for the H01. We will just come to this place after calculating our DH. All we just have to do is to just what? Input row 1. That's for H01. We put the whole of row 1 here. So assuming the next one, we just put the whole of row 2. We put the whole of row 3. That's it. That's our DH. So by the time we put the whole of row 1 now in this place, so any place we see D, here that's D now, we know that's our A1. You get, so here is our A1. Just input the theta, you put the formula of theta, you put the value of theta, you put the value of alpha. That's to just get your homogeneous. So just like I said in the beginning, TH matrix is complex in rules, but it's simple when it comes to computation. Once you can get it, you know your alpha, you know your theta, you know everything. By the time you just be inputting the formula, that's finished. So
Wait,
guys,
Samuel, can
yeah?
you go to the first manipulator you treated? I want to check something. Can you go there?
I have
This
less
one,
than 2 minutes, Sama.
Yeah, the first one.
this one, I'm seeing it.
Yeah. Samuel, that 90 degrees at that
Yes.
alpha place, that 90
Okay.
degrees.
Yeah, this
How
one.
did you the second one was straightforward. I understood how you got that 180
Yes.
degrees. But this
Yeah.
one, if you turn it, it's looking like 45, not 90. I don't understand you guys together 90.
No, there's no 45 for this.
I
The
know there's
list.
no
See,
45.
look at this. What? Let's start from our definition of alpha. What's our alpha?
Yo, you
The
have less than
rotation
1
of
minute.
this. Calm
Current
down.
X.
I just see the rotation of this to what? Sorry, the rotation of this to this, right? With the
Yeah,
current what?
along
X1 along this
X1.
X1. So how do we rotate this? That will not look exactly like this one.
Like this. I
And
know.
this Y coming up and this Z coming down. Here to here is 90 degrees. Here to here is 90 degrees. Y coming to this
Okay.
side is 90 degrees. Z coming to this
This
side is 90
is
degrees.
90 degrees. Okay, perfect. Thank you.
You get? Should I use my hand
Yeah,
symbol to explain it again?
I get totally. Thanks. I
Exactly,
get.
exactly. So that's the end for DH. That's the end for DH class. See you guys later.
Okay, yeah.
Our-
And Samuel,
yeah?
come now. Clockwise is negative, while
Yes.
anti-clockwise is positive.
Anti-clockwise is positive. Clockwise is negative. Don't mix it up. Anti positive. Just inverse it. That's all. Okay, any minute, less than 1 minute, any minute from now we are done. I think everybody grab the glass, right?
Yep.
So we can call it a day. Bye bye. So that's DH.
Samuel, God will bless you.
Amen.
Thank you, Samuel.
Amen. Bye bye.
You
Bye
live
bye.
long.
No one here has done the test by instinct.
Have you done your own?
Which test? Is this simulation?
The quiz, sorry, quiz.
Simulation quiz.
Yep.
No.
I've not done it.
13 seconds, 11, 9, 7.
Are you on WhatsApp now?
When is the deadline?
2.
For the